Hello, everyone. Welcome and thank you for taking time and joining us today. Today's topic is Zero Trust and DevOps, strengthening cybersecurity in complex environments. My name is Piyushri, and I'm joined today by Rick Brown and Jacob. A little housekeeping items before we get started. I'll encourage you all to subscribe to our YouTube channel to view other webinars on similar topics. With that being said, it's my pleasure to introduce our speakers for today, Rick Brown and Jacob George. Rick Brown will delve into the topic Zero Trust, which is one of the most hottest security terms these days, and how Progress Chef can help. I will now hand over to Rick. Rick?
Thanks, Piyushri. Okay, so hi everyone. As an introduction to myself and what I do at Chef, I've got a little slide here that talks about me being a principal sales engineer. So let's break those three things down into what do each of those mean. Principal means I've been doing this for a long time. As you can see, I've got thinning grey hair. Back in 1991, I was doing second line Unix OS support. And one of my colleagues was playing around with the little kernel that he downloaded from the Usenet. It didn't have much going for it. It didn't even have term info. He was trying to get VI working, having to write his own term cap sessions. He was trying to do all sorts of things that we found normal in those times. I told him, well, that's never going to go anywhere. It's a rubbish little open source project. That was my first introduction to Linux. So as you can see, I'm a long time user of this stuff and a long time naysayer of the things that have become popular. From there, I've been migrated to automated testing tools, to API tooling, virtual services, APM, and all things around DevOps for all that time. So that's what principal means. Just been doing this for an awful long time. The sales bit of principal sales engineer means I've worked for a lot of companies in that time. So Blast from the Past is the digital logo. So yes, I worked for DEC, also worked for Mercury and IBM and Oracle, etc. Now at Progress Chef. In those years, again, part of sales, I've been on courses for enterprise selling and solution selling, value-based selling, along with how to do things like implement SAFe and ITIL practices and ISEB. And the final bit of principal sales engineer is the engineer bit. I know little bits of Java. I know little bits of Python. I can swear at Git or Subversion. So I have a very thin layer of engineering knowledge. So what that means is rather than an engineer, it's more like an engineer. So it's a very slight veneer of engineering processes on top of all this other stuff that I've got. I like the term principal sales engineer so much, I've put it in my LinkedIn profile. The problem with that is that anyone who goes and finds me on LinkedIn is now going to see that it says engineer, and they'll think that either I can't spell or I'm not detail oriented enough to spell it correctly and to care. So any ideas about how to improve my LinkedIn profile to say why it says engineer will be very welcome. But anyway, so that's me and principal sales engineer. So what are we talking about within Zero Trust? Really, as technology continues to evolve and scale new heights, challenges associated with cybersecurity are also increasing simultaneously. Digital transformation endeavors and growing remote workforce has continued to introduce newer security threats, forcing organizations to implement stronger, more reliable security strategies. Based on the principle of never trust, always verify, Zero Trust is the most preferred security strategy used by organizations today against malware, phishing, and data exfiltration attacks. The traditional approach to securing corporate information resources assumes several things. Every endpoint being used to access resources is owned, issued, and managed by the enterprise. All users, devices, and applications are in fixed and predictable locations, usually on corporate network behind a firewall. A single method of verification at the point of initial access was sufficient. Corporate managed systems with the same classification could all inherently trust one another. Over the years, we've come to acknowledge that these assumptions no longer hold true thanks to mobility. Bring your own device, cloud, and increased collaboration among partners. The consumerization of IT has prompted users both to demand a more customized environment and to insist on using their personal devices without corporate management. Attackers that make it past one verification point, such as a firewall or user login, can exploit inherent trust and move laterally within a network, application or environment to target sensitive data. An insider that starts within a trusted zone can escalate privileges. We can no longer assume that internal entities are trustworthy, that they can be directly managed to reduce security risk, or that checking them one time is enough. So Zero Trust is an IT security model that requires strict identity verification for every person and device trying to access resources on a private network, regardless of whether they're sitting within or outside the network perimeter. No single specific technology is associated with Zero Trust. It's a holistic approach to network security that incorporates several different principles and technologies. And so what you will tend to see is that there are a few vendors doing some SSO style stuff, and that is the front end or the front door to your Zero Trust. So from a workstation, you might log in through Google Authentication or Microsoft or those other ones. So they are the people that you will interact with most often when from a workstation you're doing Zero Trust. Zero Trust really has five pillars, and they're listed here: identity, device, environment, etc. But basically it's who are you, where are you, what device you're on, and what capabilities does that device have, what application do you need access to, and what data do you need access to. And we need to have the minimum access that's going to support all of those five things. So who are you, where are you, what are you on, what application, what data. But because we're in DevOps, we also need to do orchestration and automation of this stuff. Because we're doing automation, we have the ability to get analytics. And because we're doing all this stuff, we want to have governance around it to carry on meeting our DevOps principles as well as our Zero Trust principles. But it becomes even more complex when we're doing DevOps, because it's not just access to the corporate network we need. If you're around at the days when software-defined networking came in, they brought in different access layers for different securities or different protections of network layers. So in software-defined networking, they brought in the concept of northbound and southbound APIs and northbound and southbound data. And so northbound being the most secure system, so here listed at the top in production network, that's a secure network. That is the northest of northbound. A northbound API means that the production network would be able to receive commands from any less protected network. And Zero Trust says we can't do that. Or let's say software-defined networking, northbound, southbound interfaces say we can't do that, and Zero Trust has taken that on. Data can flow both ways, that's no problem. And the production network can make calls out to lower protected networks, but we can't have anything from a less protected network pushing data into our more protected networks. It just breaks the trust model. So we have to find some way of supporting all of that stuff at the first time. So there's some architectural pillars of Zero Trust. The first basic principle is to authenticate and verify access to all resources. Each time a user accesses a file share, an application, or cloud storage device, we need to re-authenticate that user's access to the resource in question. You have to assume that every attempt at access to your network is a threat until confirmed otherwise, regardless of location or access or hosting model. To implement this set of controls, remote authentication and access protocols, perimeter security, and network access controls. The least privileged access concept is a security paradigm that limits each user's access to only the access they need to do their job. By limiting each user's access, you prevent an attacker from gaining access to a large amounts of data with a single compromised account. First, discover where your folder permissions expose your sensitive data and remediate over permissive access. Create new groups and assign data owners to manage those groups, and use these new groups to implement least privilege access. Audit access and group memberships on a regular schedule, and put data owners in charge of who can access their own data. For example, IT shouldn't control access to the finance team's data, the finance team should. Zero Trust principles require inspection and verification of everything. Logging every network call, file access, and email for malicious activity is not something a human or a team of humans can do. Monitoring and logging are arguably the most important capabilities to maintaining Zero Trust security model. With monitoring and data security analytics in place, you can tell the difference between a normal login or a compromised user account. You will know that a ransomware attack's in progress or if a malicious insider is trying to upload files to their cloud drive. This kind of cybersecurity intelligence is difficult to achieve. Most tools in this category require you to code overly complicated rules or generate a significant number of false positives. The right system will use individualized baselines per user account and detect abnormal behaviors based on perimeter telemetry, data access, and user account behavior. What this combination of efforts accomplishes is to move from the triangular DevSecOps approach that includes DevOps and security to include a fourth dimension, which is compliance. Okay, so how do we incorporate Zero Trust with what we're doing in Chef? Well, when it comes to Chef's approach towards Zero Trust, there are three major components or three steps or three parts to it. First one is establishing the trust. The devices that are within the network are identified and checked. Then a local agent is installed, which gives regular status of the devices from time to time. After installing this local agent, one can establish trust with that device by checking the device context and identity, the health and status, alongside all the relevant attributes like compliance state and so on. Secondly, enforcing trust-based access. Just because a local agent has been installed within the device doesn't mean that the user of that particular device gets to access everything within the server. There are certain limitations imposed over here with respect to network, like applications that can only be accessed by connecting to the VPN. Limitations based on the type of work was also imposed on the users. Users are granted access on those applications and resources which are needed based on their job profile. And the third one, continuous trust verification. The users within the network are continuously verified. They're asked to change password, and once that's changed, users are automatically logged out of their devices, asked to carry the verification steps again. IT managers can continuously keep an eye on the list of devices along with their activity and behaviors. A unified dashboard to track the current status of nodes in terms of configuration, health, and compliance makes it furthermore easier to track security and configuration management data across the entire IT resource fleet. And so benefits of using these three approaches include the prevention of network access and lateral movement using compromised or stolen credentials, gives you a single pane of glass visibility to your entire fleet. So we're talking about workstations here as well as what's in the prod systems. It gives us monitoring and inspection. It gives us, it doesn't interfere with the user experience for accessing applications. So the single sign-on method you go through from your workstation, that hasn't changed. We're putting some extra checks in the background that they use. The users don't get to see those. Policies can be deployed to every workstation or to every server for access to specific resources, and we can restrict access to the high-value resources on managed devices. So if we take an example of this, we've got these applications that we want to get access to. So we need to reach them. So how are we going to reach them from our user on our device? Well, historically, and the easy solution is we just plug into the network and away we go. But of course, COVID's happened. We don't go to work. I'm talking to you from my home. I'm sure some of you are at home as well. So we don't have access into the corporate network. Historically, what do we do for that? Well, historically, we have a VPN and we have a username and password. Once we have our username and password, then we are connected directly to to the internal network as if we were logged in. We can get access to everything again. But that has a trust assumption. So the trust assumption is the employee is the right person and the credentials are valid and the machine's doing the right things, etc. So there are some risks associated with this. What happens if there are stolen credentials? What happens if the employee is left and we haven't deactivated accounts? What happens if the device they're on has any issues? This is where zero trust comes in. We need to have, or to find some way of having a zero trust layer between making our connection and getting access to the application that we want. And so zero trust includes a rules engine. So all of those SSO vendors that we saw earlier, they include rules engines. And rules engines can validate the credentials of the user. They can validate the device that people are on. They can validate that the user is a real employee of the company. They can check patch levels, etc., etc. And so, as an example, if an employee wants to get access to email, then they go through the rules engine to say, is the user the correct user, and are they on a company-owned device? But that's it's a very basic rules engine. What you need to do to increase this to a zero trust rules engine is to grab data from elsewhere to see, does our device meet the policy, meet the policies that we want to impose on that device? Is it hardened? There was a CVE a couple of weeks ago on MS Outlook specifically. Okay, without having the rules engine combined with zero trust, we're not going to be able to tell, is the version of Outlook that the user is on, is that a compromised version? Okay, what we need to do is to find a way of getting the information from the device, preferably out of bounds, so we don't slow down the connection process, to make sure that the device has the right hardening profiles, it's on the right version of applications, all that kind of stuff. So that's a zero trust way of implementing remote access to email. Okay, so what about another one? So SSH. You need to have certs for SSH. So you need to have the rules engine to say, do we have the right credentials? Do we have the right user? Is the user able to access the cert? So again, all those zero trust things that we went to before. Once the cert has been successfully ticked to say yes, you can have it, well, we should go through the rules engine again and say, okay, that employee on that device, can they apply that cert through the rules engine and get through our VPN, etc., to get to the terminal that they need to get to? But again, it's the rules engine implementing the SSO that enables all this stuff to happen. So how does this look operationally? Well, here we have a picture of our production system with our funnel of people accessing it. So it could be users, it could just as easily be customers, connecting to that remotely over the cloud. And so this is a zero trust mechanism because we've just gone through all of that stuff. Of course, zero trust, we need to include things that are going to help us with network security. I mentioned about logging and metrics and all that kind of stuff as well, and the reporting. So you need to include some kind of network and application security as well with that. But that can easily be a zero trust mechanism. But we're talking about DevOps specifically here. And so as a DevOps engineer, I need to access the production boxes. We need to install new security updates. We need to upgrade software. We need to implement new Kubernetes clusters, all that kind of stuff. And so we do that from our dev workstation or from our DevOps workstation. Unfortunately, if I connect from my DevOps workstation into production, well, I'm breaking all sort of security models. I showed you the SDN northbound and southbound. Well, production is the northest of northbound. We can't get access to there. That would be a trusted connection. We can't do it. We're not permitted. But remember, we've still got that rules engine from Zero Trust. And the rules engine says what the specifications are, what can we do into production. We need to do it in an automated manner. It makes sure that we understand what credentials we need, how we need to do it, where from, and all that kind of stuff. So what we do in Chef is that we generate all of our assets, all the things that we want the production system to do, and we test them locally. And once they're tested locally, we can put them in version control. And then because we are doing DevOps, we can get automated systems to come and grab the version control and build to put into dev and test environments, go through quality gates to then put into deployments and finally into secure repos so that we can get the changes put into production in a zero trust manner. And so that zero trust manner then means that the Chef users on the left-hand side of this diagram here then have a zero trust way of operating into our production environment. But how do we get there from where we are? Well, every company in the past 15 years that I've talked to has talked about going through digital transformation. You need to do digital transformation before you can do zero trust in DevOps, because you need to have the working CI/CD pipeline. So you'll see here on the left, we've got our user, our DevOps engineer, doing his local work and stores data inside some kind of version control repository. I've just listed it here as a Bitbucket or a GitLab, some kind of a Git repository. And the CI/CD pipeline picks stuff up from there and sends it into the whole of the rest of the human-free zone that ends up in production. So production has direct links to secret storage. It has direct links to the artifact repositories. It has direct links to whatever Chef is doing into it. But it is there and sacrosanct and is the thing that holds all of the base security models to say what can I pick data from. I can pick data from artifact repository, Chef server, and secrets in this instance, but nothing else can have any connection to production. So we are safe from users performing bad actor tasks against it. We're protected from any other systems that might have any malware, any misconfigurations. We are just getting the data that we want, the information that we need. And so that's what we really want to do in production. So how do I get there from where I am? Well, we need to talk about where you are. Where's your CD pipeline? What are you using as your source and your artifact repositories? How are you doing your secrets management? All that kind of stuff before we can get into proper zero trust to DevOps. And we've got some resources here. These will be linked for you later when Piyushri sends out the presentation to everyone. Links to some blogs and some webinars that we've got for this kind of stuff. But having said that, how does Chef actually fit in to all of this stuff? So here we have an example. So this is specifically talking through our rules engine, which we're calling here Smart Proxy. Smart Proxy talks to the SSO thing, and the SSO server says, okay, let's have the access control. We'll talk to your access control systems. So that grabs access policies, and it grabs data from data sources like who the user is, what machine are they on. Then we've got this thing called other sources. So your SSO needs to grab information about the device that the user is connecting through. And the information that it's going to grab are going to be things like, what's our version of Outlook? Are we using a version of Java on a machine that has any problems? All this information is sort of CMDB-like information. And that CMDB-like information is captured by Chef every few minutes. We're grabbing compliance data, or the machine sending compliance data into Chef, and our SSO is querying the the Chef data source to combine what capabilities does my machine have, part of the Zero Trust, with those other 5 pillars. So who am I? Where am I? What machine am I on? What application do I need? What data do I need? And part of the what machine am I on is what capabilities does that machine have? Is that machine in compliance? And so there is the SSO system asks the questions: did the Chef client run less than an hour ago? Did the compliance profile pass at that point without any critical fail controls for the application that we want to grab? Is the user in the right AD group? If all of those are correct, then yes, we can send data through. To help with some of this stuff, Chef can provide some security profiles that are CIS compliant. And if you want to extend those specifically for things in your own industry or things that you need to look at for your own company, then those our controls can be extended with your own, so that you make sure that we know the compliance state of any of the machines in our estate, from workstations out at someone's home all the way through to our prod web server. And so how we do this is that if we start on the right on this one, we have humans doing cookbook authoring and doing profile authoring, generating the assets that we want, and we save them into the Chef server. Also into the Chef server, we have all of our devices, all of our servers, everything that's running our Chef agent, and they are grabbing compliance policy to say what they should be doing, and they're sending in reports to the Chef server saying what it is that they have, what is their compliance status, all that kind of stuff. All of that compliance data and inventory gets sent into Chef Automate, which gives us APIs that the auth provider then accesses out of bounds. So when a user tries to connect, then in the back end, the SSO auth provider goes to the Chef Automate API, says, give me information about this node. Is this something, or does this node have the right capabilities? Does it have the right compliance status? Is it using a compromised version of any of the libraries that we want? All that kind of stuff. And then on the human side, again, we can get visibility, we can get reporting straight out of Chef Automate, and we can even integrate with things like ServiceNow to give help desk reports or help desk views on the compliance status of all of the machines that we've got that are connecting into our network. And so that, in a very quick nutshell, is all about Chef and Zero Trust DevOps. So at this point, I'm now going to shut up and let Jacob come online so that we can go through any questions that have happened in the past half an hour.
Thanks, Rick. That was a really good presentation. It's really well explained how Chef actually is really important for applying Zero Trust inside your environment. But I don't think we have any questions as of now. So if anybody from the audience, if you guys have any questions, we can get them answered now. If you are watching this at a later time, you can always contact us with the contact information that we are providing as well.
Okay, so if that is the case, and while I'm talking about this, we can see if any questions come in. If they don't, then I will move from the Q&A slide to the next one and say thank you all for your attendance. And we've been progress talking about Chef and Zero Trust in DevOps.